The earth is a rich and vast storehouse. From it come all the materials that we use. One of the most important of these materials is copper. Without copper, our modern world as we know it could not exist. Copper is found in many places throughout the world, but perhaps the largest single copper mining operation known is this open-pit mine at Bingham, Utah, in the United States. To uncover the ore, it is necessary to blast down and haul away mountains of earth that lie on top of it. To prepare for blasting, workmen first drill vertical holes. The steel drill has a hole down its center, coming out at the bit. Water passes through this hole to keep the bit cool as it grinds its way through earth and solid rock. When the drilling is done, a long blowpipe is dropped into the hole. Air under pressure is blown in, shooting out all water, mud, and loose dirt, leaving the hole clean and ready to be loaded with dynamite. Horizontal holes are drilled in the same way. Explosions in these holes cut out the bottom of the walls to keep them even. Explosions in the vertical holes blow down the great masses of earth and on lower levels of ore. Vertical holes are loaded with granulated dynamite. It is poured and tamped tightly to the bottom. Stick powder is used in the horizontal holes. About 375 pounds of powder are loaded into each one. It also is tamped solidly to the end. And now, blasting time. After blasting, the great power shovels go to work to haul away the earth that covers the ore. Trains of empty 100-ton cars are run into the blasted down sections, and the shovels begin loading. 125 cars of earth are moved to every 100 cars of ore. As the levels of the pit are blasted back, railroad tracks must be moved back also to bring the empty cars alongside the shovels. This track mover picks up both itself and the track and jolts over sideways to the new position. In the lower section of the pit, ore is loaded. The ore rock is grayish in color, but only 1% copper. Sometimes you find richer pieces with so much copper mineral you can see it in the rock. As the cars are loaded, they move out of the pit and are coupled with others to make up a single long train. Then they head for the mill. Arriving here, the train is split up and a few cars at a time are backed into the tipple for dumping. 2 cars move on and are turned upside down. The larger chunks of ore are caught and broken by this big crusher. The smaller pieces go right on through. Then the ore moves on conveyor belts from one crusher to another, being ground into finer and finer pieces. Finally, it reaches these great steel drums, or ball mills. Each drum contains 22 tons of steel balls, which grind the ore until it becomes almost like powder. New balls are added every day. and when they come out again, they're almost worn away. In these ball mills, too, water is mixed with the ore, which now is so fine and powdery, it makes the water muddy and thick as it leaves the big drums. Chemicals that make froth are added next. Ore particles containing copper stick to the frothy bubbles which rise to the top of the water. This is called the flotation process, because the powdery particles containing copper, known as copper sulfide, actually float to the top with the bubbles. Now this froth is drawn off the top, while the mud and waste are drawn off underneath and carried out to this dump, which covers 7.5 square miles. The copper sulfide is removed bubbles by these disc-shaped canvas filters. Strong suction causes the sulfide to stick to the canvas as it rotates through the bubbles. Next, the suction is changed to pressure, and the sulfide falls off. It is now copper concentrate, 30% pure copper. From the mill, the concentrate goes to the smelter, where it will be made 99% pure copper. Here it is emptied from the railway car by this big shovel. Other ores containing silica, iron, sulfur, and other minerals must be added to the copper concentrate before smelting to make it heat and burn more rapidly. Here a carload of these ores is dumped. After the ores have been added to the copper concentrate, the mixture is hauled to the roaster. Now the heating and burning process begins. Sulfur burns first. That is what you see here. From the roaster, the ore mixture, now called calcines, goes to the great furnaces, where for the first time it becomes hot enough to melt. These furnaces reach almost 2,800 degrees Fahrenheit. In its molten form, the copper ore mixes with other elements such as iron, silica, and lime to form what is called copper matte and slag. The slag is waste. It is hauled out and dumped. The molten mass cascades down the side of the dump like lava from a volcano. Back inside the smelter, the molten copper matte is drawn from the great furnaces in huge buckets, handled by overhead cranes. It is now dumped into the converters. This long section of the smelter is called the converter aisle. It is filled with noise, smoke, and heat. In the converters, air is blown through the molten mixture to help burn out impurities. Finally, there remains the molten copper, approximately 99% pure. It also contains small quantities of precious metals, such as gold and silver. Now the molten metal is poured into molds to form ingots of blister copper. They are cooled by streams of water. They come out of the bath still steaming and too hot to touch, except with hooks and asbestos gloves. Workmen load the blocks, weighing 500 pounds each, onto hand trucks and take them immediately into waiting boxcars, where they are to be shipped to refineries for further processing. After this refining has been done, the copper will be made into telephone cables, electric wires, copper sheets, wrappings for motor generators, and 1,000 other items that serve you and your home every day. As you pick up your telephone, start your vacuum sweeper or food mixer, remember that it is copper, coming from the great storehouse of earth, that makes possible these useful items around your home. Copper is the servant of our electrical age.